Today's daily LeetCode problem of the day is range sum of sorted subarrays number 1508. For this problem, we're given our array nums and it has n positive integers. We want to compute the sum of all the non-empty continuous subarrays from the array and sort them in non-decreasing order. This will create a new array of length n times n plus 1 divided by two numbers. We want to return the sum of the numbers from index left to index right in our new array. Since the answer could be huge, we're going to modulus 10 to the 9 plus 7. So our original array is nums, 1, 2, 3, 4. It has a length of 4. And in our new array, we're going to want to look at indexes left and right, starting from 1 and going to 5. But we got to remember that it is indexed from 1. So 1 in this case would actually be 0, how we normally think of arrays. So for our array, we're going to want to take 1, and then 1, 2, and then 1, 2, 3, and then 1, 2, 3, 4. We're going to count those sums and add them to our new array. So if we look down here, we have 1, 1 plus 2, 1 plus 3, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4, and then we do 2, 2 plus 3, 2 plus 3 plus 4, and then we do 3, 3 plus 4, and then just 4. We then want to sort them in a non-decreasing order. So we have 1, 2, 3, 3, 4, 5, 6, 7, 9, 10. And then we're going to get from the index left is equal to 1 and right is equal to 5. So 1, 2, 3, 4, 5. So 1 plus 2 plus 3 plus 3 plus 4 is equal to 13. Pretty simple. So for this problem, we are first going to initialize a new array of sums of subarrays. We will then be able to fill subarrays, sort those sums, and then collect final sum to return. So to initialize our new array, it's going to be an integer array. We could call it our subarrays. And it's going to be equal to a new int array, and it will be of length n times n plus 1 divided by 2. Because that is the total maximum amount of sums that can be created from our original array. So on top of our new array, subarrays, we're going to have an integer temp, which is going to store the temporary value we'll be adding to subarrays, and an integer index that will represent the index in our subarray. We're then going to fill our subarrays, so we're going to have a nested loop and I is going to increment throughout nums, so for int I is equal to 0 as long as I is less than n, I plus plus. And our temp value is going to be equal to nums of I. So temp will automatically be equal to nums of I. Then for our second loop, for int j, j will be equal to I. And j is going to be equal to I, so that way we know if we need to add nums of j to it or skip. So j is going to be less than n, j plus plus. So like I was saying, if j is equal to I, we want I to just be added to our array, because if we look at our example, we're going to have each of our numbers in the array automatically, because it's going to be 1 plus 0, 1 plus 2, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4. So if j is equal to I, we're going to have all of index, and then we're going to increment index after the fact is going to be equal to temp. Otherwise, we're going to temp plus equals nums of j, and we're going to add that to our array. So we're going to have, this is subarrays. So subarrays of index plus plus will be equal to temp. Now that we have our subarrays filled, we can sort it by using the arrays.sort function and just adding our subarrays array to that. So that's sorted. Now we just need to collect our final sum. So we're going to have an integer sum, which will be equal to 0. And then we're going to increment from our left pointer to our right pointer. So for int I is equal to left, as long as I is less than right, less than or equal to, because it says it is inclusive. So less than or equal to right, I plus plus. And if we look again, it says it's indexed from 1. So we're going to have to subtract 1 from I will be added to our sum. So sum will be plus equal our subarrays of I minus 1 because it's indexed at 1, not 0. Then to prevent a huge number from turning negative, we are going to sum modulus equals math dot the power of 10 to the power of 9 plus 7, or infinity. And then we can simply return our sum. So if we run this, passes our test cases, and if we submit it, it'll pass all solutions. So let's do this in Python. For a Python solution, it's basically the same thing. We're going to initiate our subarrays. It's going to be an array of zeros. It's going to be of length n times n minus 1, plus 1, divided by 2. We're then going to have our temp is equal to 0, and our index is also equal to 0. For I in range from to range n, temp is going to be equal to 0, and for j in range, it's going to start at I and go to n. Temp plus equals nums of j, subarrays of index are equal to temp, and index will increment by 1. Then we can do subarrays dot sort. Sort it real quick, and then we'll have sums is equal to the sum of subarrays from left minus 1 to right, because it is 1 indexed. Then sums percent equals 10 to the power of 9 plus 7. Then we can return our sums. So if we run this, pass our test cases, and passes all solutions. Thank you, and follow for more daily LeetCode solutions.